Remember, think about what you know, right? What do I know about this from the last unit, and how can I have it answer that question? Now, it says you can use Desmos or a graphing calculator to help if you need. If you don't need that, it's actually, there's a way to get this warm-up done super quick if you remember what these things do. Yeah?
Can I say it?
Well, can you tell me what a vertex is?
The starting middle point?
It's the middle point in a quadratic, in a parabola, right? It's that spot in the middle, right? Yeah, lowest or highest point, right? What else do you want to add to that?
If we just do what we did last unit, wouldn't it be the first one 2, -4?
Correct. But, so, how did you get that?
Well, I know that -2 means go right 2,
Mm-hmm.
and then down 4, that's -4, 2, -4.
Exactly. So, if we think about our parabolas, right? We don't have to do this drawing every time, but let's think about what we know here. We know that the parent was here, right? And this makes you go right 2, and this makes you go down 4. So that would be right 2, down 4, new parabola with the point here must be, like you said, 2, -4. So 2, -4 is R. Yeah. We don't need to graph that every time. It's important to understand why that's our vertex. That's the why. But the trick of it is using the structure. Now, that's another one of our practices, right? Can we use structure to help us find an answer? Remember in linear equations, it was like we had slope-intercept, we had point-slope, we had standard form, and then like slope-intercept, you use the structure to say, oh, there's the slope, there's the intercept, right? This is what's called the vertex form of an equation, of a quadratic equation. The vertex form of a quadratic equation gives you the vertex right in the form. You can look at the structure of it and say, oh, I know the vertex, right? No math needed other than your ability to recognize the structure. All right, so let's come up with a rule here for pulling that vertex out. To get my x, what do?
What? Well, find it. Opposite.
Look in the
If it's inside.
Go inside and do what?
switch.
Switch the sign, right? So x is inside, flip the, well, just say the sign. And to find our y, we go
Straight up.
straight up, outside, keep it, right? Outside, keep the sign. Okay, so I'll give you another minute if you were not sure about that to keep working on this. But really, once you know it, it should be pretty quick. There are a couple that have a little trick to them. We'll talk about those as well. So your vertex, right, is made up of an x and a y. It's a point. You get your x inside by flip it, and you flip the sign, so it becomes 2, right? Positive 2. And you keep the outside for your y. Okay? So for instance, the next one would be what?
-1, 8.
Yep, -1, 8. And then what about this next one? Wait, hold on. This one has a 3 out front.
But it doesn't change anything.
Exactly. So a lot of people are wondering what do I do with the stretch? What do I do with the stretch? We've done a lot of parent functions. Has the stretch ever changed the vertex? No. The only thing that changed the vertex is the right, left, up, and down. So the stretch, this factor, does not affect the vertex. Okay, so what about this one, though?
4, 0. -4, 0.
I'm confused. Where'd you get 0 from? Talk to me in terms of right and left. and then talk to me in up and down, and then talk to me in terms of the vertex form of this function that we just talked about. Pick one. Go ahead. No? Okay.
Wait, I have to tell you what happened?
Yeah. Why is it negative 4, 0?
So like inside plus 4, so it's
Mm-hmm.
and outside there's nothing, so we can't go either up, either down, so it's 0.
Good. What if I told you there was something outside?
If there was, but there's not.
So plus 0 out there, right? Did I change anything by adding plus 0?
No.
No. And now it's in that form that we recognize, and it confirms that we have it right. Okay? This one, 7, 2, right? And then this one,
0, 3.
okay. Again, you can. It sounds like you remember your parent functions, and you know this thing goes down. It doesn't go left or right. Who could talk to me about how to make this equation look right?
What do you mean?
What do you think?
What do you mean by that?
Well, remember, can I make it look like one of these equations? And we're going to get into vertex form, but I'm going to see if we can make it fit the structure.
Just put the x in parentheses.
Okay?
The x is pretty easy, but
How much does it move left or right?
No, just close it and
it
put the
moves
square
0.
outside.
So it's plus 0.
Plus 0 squared minus 3. Have I changed anything?
It doesn't matter though if you put the plus 0.
Well, if we want it in this form, it does. You're right that it doesn't change the result. We're just changing the form.
I think it's saying like you can do plus or minus.
Oh.
Like, we can just put x in parentheses. That's it.
Right, but
Because, like,
so vertex form is a very specific thing. It goes y equals a times x minus h squared plus k, and we're going to get into all that, right? You need something in the h spot if you're writing in vertex form, technically. But that's okay. This was more of an experiment. Okay. All right, so yeah, that was vertex form. Okay, so let's start defining polynomials. Let's start moving along here. Okay, a polynomial, its definition. It is defined as, well, a sum of terms with the same variable. Okay? The sum of terms, there's fancier ways to define it, but that's basically what it is. It's the sum of terms with the same variable. For instance, you could have like x squared plus 2x plus 4. That would be a polynomial. Okay? All right. But before we get into more examples, let's talk about that word term, right? What is a term? Anybody know what a term is? Glad we're covering it. Okay, a term is a number and a variable. And it's the product, it's multiplying them. So for example, you might have 3x. You might have x squared. You might have 7. Okay? Now, maybe I have an issue with my definition based on the examples I gave you?
Yeah.
What's your issue?
Well, okay, I think I know, but 7.
What's wrong with 7?
There's no variable.
There's no variable. What about x squared? There's no number. So how do we reconcile this? Well, there's a 1 in front of the x squared. And what about with the 7, though? There's no variable. It is there in spirit. There's a little imaginary x to the 0 next to it. No, this isn't imaginary numbers. I was just using the word imaginary in a funny sense. X to the 0 is 1. 7 times 1 is 7. So that's how you can justify this definition with with those situations. So there's a little 1 in front of that, and there's an x to the 0 after that. All right, give me some more examples of polynomials. How about let's go with 3x, x squared plus 5x, and let's go with 7x to the third minus 3x squared plus 10. Okay, those are all polynomials. Anybody have any issue with these based on our original definition?
These are definitions.
So our definition was a sum of terms with the same variable. Here are my examples. Here, here, and here. Well, what do you see in that word, in that definition, the word sum? What does that mean?
Addition.
Addition. So you're adding terms together. Which of these kind of violates that a little bit? Bottom one has a minus in it. So don't let that get you tripped up. You can always think of subtraction as adding a negative, right? 5 minus 5 is the same as 5 plus minus 5. It's just written a different way. So it's still considered a sum, okay? The other thing is, if you have 3x, that's just one term. But you can think of it as 3x plus 0, and now it's two terms, and it fits the definition of polynomial, okay? All right, so there are three types that we're going to make sure to talk about. Monomials, binomials, and trinomials. Okay, so what does the word mono mean? Anybody know? One. If you ever forget that, think about like mono a mono. It's one-on-one, right? Mono is one, so that is one term. So for instance, you might have 5x, 3x squared, or just like 10, right? These are all examples. Okay? Now, how many wheels does a bicycle have? 2. So how many terms do you think a binomial has? 2 terms. So you might have x plus 10, x squared minus 5x, or 2x minus 50, whatever, right? Just 2 terms. Okay? So what do you think about trinomials? 3. Tricycle, right? 3 terms. Triceratops. 3 horns, right? Okay. So this is where we get into our classic quadratics. Like I might have x squared plus 4x plus 4, or like 2x squared minus 15x plus 32, right? Those are trinomials, okay? Now, anybody know what you would call something with 4 terms? Good guess. No, at that point you just call them polynomials. You know, there's no more words that they use. They go monomials, binomials, trinomials, anything bigger than that, it's just a polynomial. Okay? These are all polynomials, but we just don't have extra terms for those. Okay? So what we need to talk about today is mostly how do you multiply these things? How do you multiply polynomials? Okay? That's one of them. That's coming. It's coming. All right, so yeah, there's 2 main methods for multiplying. We're going to be multiplying. They're going to be multiplying. All right, so before we multiply, let's talk about this term thing again. So let's say I have the term 5x. Okay, that's my example term. Everybody knows that x is a what? An unknown number, the word we use for that is variable, right? Does anybody know what that number is? The number in the front. No, the factor is when it's in front of an equation. Yeah. It is an integer, but there's a special number when it's in front of a variable. It's coefficient, yeah. Coefficient, and that's a word we're going to use, so you want to recognize it. It's the number in front of a variable that's being multiplied by it, right? Okay, what if I had this minus 10? What is the 10?
That one is
What do you call that?
a number.
It's a number, but in this situation, it's the what?
Process.
All right, I'll give you a hint. This term right here is kind of going to depend, right? 5x, well, it depends on what x is, right? Does minus 10 depend on anything?
No.
No, it will always be minus 10. It is
Independent.
independent.
Solo, by itself,
Alone.
single.
It doesn't change. It's
Constant.
constant. It's your constant.
It's constants.
Constantly single.
Okay? So we'll be using those terms. Okay, so monomials, we do need to know the term. That was good that we talked about that. Now, there's 3 situations for multiplying monomials, okay? You have mono times
You don't have like a
mono.
Yes, it is.
Yeah, that's not the one we're talking about. You have mono times binomial. And you have mono times trinomial. In order to do the second 2, you got to kind of know the first one. Okay? And the first one is as simple as you might have like 3x times 4x. Okay? And maybe you've memorized, like your brain just clicks and goes, I know that that is boom. But I want you to think about it in terms of what's actually happening, because a lot of times when we're in the middle of a problem when we have to do this, like when we get over here and this is like inside the problem, we mess it up, we forget. Think about what each of these is saying, right? What is 3x? 3x is what? Well, what is 3 times x saying? Oh, I just said it. 3 times x, right? It's 3 times x. And this is 4 times x, right? So if you have a bunch of things being multiplied, well, this is really 3 times x times 4 times x. And when you're multiplying a bunch of stuff, right, you multiply what you can, and then you leave it, right? So what can I multiply by each other in this situation? 3 and 4 gives me 12. What else can I multiply by? X times x is x squared. Can I do anything more with 12 or x squared? No, so I leave them written as the expression 12 times x squared, because that's as far as I can go with it,
Do we have
right?
to write 12 times?
No, you never have to. But I want you to understand why this becomes this, okay? It's because you're multiplying what you can, and then you're not going any further than that. Yes, question?
Why is it squared?
Because x times x is x squared. So that is a key thing. You must multiply both the coefficients and the variables.
I thought it wasn't called a variable.
It is. That's a variable. Okay? You have to multiply both. And I think where people get confused here is they're like, well, 3x, when we add 3x and 4x, it's only you add the coefficients and you keep the variable. You don't do anything with the variable. 3x plus 4x is 7x. But when you multiply, it's different. Yeah?
If you multiply x squared times x squared, is it x to the third power or x to the fourth power?
Great question. X squared times x squared. Well, This one is x times x, and then this one is x times x. So that's x to the fourth power. That's a good question. So you just add the exponents, yep. All right, that's mono, a mono. Okay. Now, what if I had a monomial, and we're going to up our difficulty level here. 7x minus 2x times x minus 3. Okay, what do you think is a common mistake that people might make here? Because I saw it on the test.
They don't distribute? Or
They don't distribute before they,
multiple?
well, distributing is multiplying.
They don't distribute. Before they add the thing?
Before they do 7x minus 2x.
Before they do 7x minus 2x, right? This is not 5x times x minus 3, right? It is not that. Okay? Because, well, why? Well, look what we have here. We have subtraction, and then this is multiplication. What comes first in GEMDAS? Multiplication. So I distribute first. So distribute first. Okay, distribute means, remember, everybody gets a little piece, right? So you have to, you're giving out pizza, you get a piece, you get a piece, you get a piece. You're handing out multiplication, everybody gets their multiplication, right? So what happens? Well, the 7x will just come down, and then I get minus 2x times x. Well, now I have a mono situation, right? Negative 2x times x. We got to multiply the coefficients and then multiply the variables. What's the coefficient in front of the x? 1, right? So there's a little 1 here. Negative 2 times 1 is negative 2. X times x is x squared. And then I have negative 2x times negative 3. Negative times a negative is a positive. And it's 6x. Okay? Now I can combine like terms. Where are my like terms?
7x and 6x.
7x and 6x. So I'm going to write negative 2x squared plus 13x. You don't have to start with the negative, but there is a reason why I wrote negative 2x squared first. Does anybody know? How is it bigger? Say it.
You start with the higher power.
You go highest power to lowest power. Power is your exponent. You always write highest power to lowest. So I'll write that down. Write highest power to lowest power.
So you put like a negative exponent below a regular number?
A negative exponent? That's a good question. I guess, yes, you would. I would actually say that that negative exponent should be moved to the under the fraction. But that's a whole other conversation. All right. So that's monomial versus binomial. And then monomial versus trinomial. Let's say we have minus 3 times x squared plus 2x minus 7. Okay? Again, we have to distribute. How many terms are in there? Inside the parentheses, how many terms do we see? 3. So every one of them gets multiplied by negative 3. Okay? And we end up with negative 3x squared minus 6x plus 21. Say again?
None of them are like terms.
We don't have any like terms this time. So we're done.
That's all?
Yep, so that's all you would do there. Now, what I will say is that eventually, in this unit, we're going to try to go that way. Eventually, we're going from that to that, which we'll teach you how to do, but think about it. To get from here to here, what did I do? I multiplied by negative 3. So how do you think I would go backwards? Divide by negative 3. If I divided this by negative 3, this by negative 3, and this by negative 3, because I saw it went into all 3 of them, well, I can't actually divide and get rid of it. I'll just pull it out front, and I get negative 3, divide each of them, and I get x squared plus 2x minus 7. And that, my friends, is called, well, it's one example of factoring. And we're going to do so much factoring.
Is that like in geometry, like standard form, and then there's like the one in the bottom that's standard, and then
Well, these are both in this is considered standard form because it's ax squared plus bx plus c. Yeah. And again, we'll have a whole lesson on standard form. I'm glad you have some experience with it. Okay, moving along. You ready for FOIL? All right. So, FOIL. Okay. Real quick, since we already did this, let me get it on here. FOIL. First, outer, inner, last, right? What does that mean? Okay, so again, it says we're multiplying binomials. That's one binomial times another binomial, right? So that might be something like x plus 7 and x plus 9, right? Two binomials, because it's two polynomials that each has two terms, okay? Now, when you multiply using FOIL, right, what you do is you use FOIL to make sure you multiply everything you need to multiply. Because if this group is being multiplied by this group, well then this has to be multiplied by everything, and this has to get multiplied by everything. Both of them do. So you end up with 4 different multiplications, and FOIL helps you cover all of them, right? These are your two situations, this one and this one, right? And you just go in order. So first would be the first in each one. So this is your first, and this is your first. These two right here. And I see a lot of students write that curve I just did every single time to help them. So x and x. What is x times x? X squared. Outer just means the ones on the outside. So that would be x and 9.
Usually I go x, then 7x, then...
So you do inner first? That's okay, as long as you cover it all. But that would give you 9x. And then on the inside, this is what you're talking about? You do this one first? That's okay. You do 7x. Yours is like Fioli.
It's like I do x, then 7x.
Okay, that's okay. And then last is the last ones, right? So it's 7 times 9, which is 63. Now you're always going to have an extra step here. You're always going to first FOIL, and then you're going to have to combine like terms. And it's going to be easy because they're going to be in the middle. So what are my like terms here? 9x and 7x, right? Those are like. You can add them together. Yeah. Yeah, you did. Do you remember it all? Yeah. Yeah, this is a review day. So if you remember this stuff, you'll be in great shape, but we're going to need this stuff a lot in this unit. So that's our answer. X squared plus 16x plus 63. Now, what did we just do? We said we were doing what with these?
No idea.
What does it say at the top? We are
First,
multiplying. When you multiply, you get a what? What's your result? A product. So this is my product. And what comes together to make a product? Specifically, a product. When your result is your product, the two things you multiplied or the multiple things you multiplied are your factors. So what does that make these? These are factors. And that's a really important word in this unit. Okay? X plus 7 is a factor. X plus 9 is a factor. I multiplied it to get a bigger thing. So when I say, hey, again, I might say, go this way, and I say factor, I'm asking for these instead of this. This is more factoring. And we will get there. Now, that's a little trickier than just dividing by 3, right? You're going to have to do some tricks to get from here to here. but there's many ways to do it, and you'll be fine. Okay? Okay. Almost done. Okay. So that was multiplying binomials with FOIL, but a lot of people prefer a different method. It's called the box method. I'm seeing some nodding heads. Yeah.
FOIL only works for binomials.
Correct. So even the people who like FOIL choose the box method for the second problem I'm going to show you. All right? So I'm going to show you two problems. Okay, so box method, it's like it sounds. We'll take that same example. I have x plus 7 and x plus 9. Right? I make a box that has the dimensions of the number of terms I have. What do I mean by that? Well, how many terms are in this first one? 2. And this one is 2. So my box must be 2 by 2. Meaning, boom, boom, like that. 2 by 2. Okay? And then that gives me a spot for every term. What's that?
You like the biology thing? Like
May I don't know what you did in biology. I'm not a biology student.
Like the chromosome.
the chromosomes.
Okay. Now what you're going to do is find the area of every box. How do you find the area?
Like something.
Length times width. In this case, if you're looking at this box, well, it's x and it's x, so it's x times x. So what is x times x? X squared. This box is 9, and what's its length this way? X, because from over here, right? So that's 9x. This box is x and 7, so that's 7x. And this box is 9 and 7. 9 times 7 is 63. Now the good thing about box method is it always gives you your like terms in a nice diagonal. So if you look, these are your like terms, right? And that's 90% of the time going to happen.
It's like a multiplication.
Can you like do or that or the other one?
Either one.
Or like you'll ask us to do like the box method?
I will most likely say choose the one that you like the best.
Oh yeah, because that I don't know how to do it.
Whoa, I want practice, so you might get good at it. All right, so then I bring it all together. I say, well, x squared by itself, 9x and 7x are together, so that's 16x, and 63 is by itself. Okay, so you can choose the FOIL method if you like, but I'm going to show you a problem where I really suggest the box method. Okay? Here's your next problem. What if you have x plus 7 again, but it's times x squared plus 2x plus 4? How do you FOIL that, right? It's foiled, yeah. Well, what FOIL really does is make sure you just strip it of everything. So you would need to, if you didn't want to use the box method here, you would need to go like this. You have to do all that, right? And you might forget one, right? The boxes, make sure you don't forget, okay? So how many terms are on the left? 2, and I have 3 here, so I do a 2 by 3 box, right? 2 by 3, and I put my things on the outside, x plus 7, x squared plus 2x plus 4, right? And then I just do every box. X times x squared, question?
Would that be x to the third power?
Yeah, it would be x, because this is x to the 1, and that's x squared. You add the exponents, right? So it's x to the third. X times 2x is 2x squared. X times 4 is 4x. X squared times 7, that's 7x squared. 7 times 2x is 14x. 7 times 4 is 28. And again, you get these nice diagonals. Look, x squareds, x's, right? So your like terms end up in these diagonals, and you can just bring them all together, and you end up with x to the third. It's by itself. These two are together, so that's 9x squared. These two are together, so that's 18x. And this one's by itself, so plus 28. And And there you go. You have your answer, right? You just did a pretty complicated multiplication of a binomial times a trinomial using your box method. Okay? Now there's one other special situation we got to talk about, and then we'll be done. Okay?
Now I understood how to do that, but the other one is easier.
Okay. Whatever way works for you. Okay? Okay. So there's one situation where you're multiplying by binomials that tends to confuse students. So let's talk about that. Anybody writing?
No worries.
Okay. All right. So what if you had what's called a perfect square? So what do I mean by that? What if you had 2x minus 3 squared? Okay. Let's again talk about what this is not. Because, oh my gosh, do people want to do this, what I'm about to show you? Okay? This is not 2x squared plus minus 3 squared. It is not that. No. Okay? And I'll show you, I'll prove to you that it's not. What is 2x squared? This would be 4x squared, and this would be plus 9, right? So this is the answer we would get if we did it the wrong way. The wrong way. You want to be clear on that. So it's not this, right? Now, why is it not that? Well, what is this? What's another way I could write this?
2x minus 3 in parentheses times 2x minus
Yeah. Anything squared is just it by it's it times itself, right? So I could rewrite this as 2x minus 3 times 2x minus 3. And this is what you do want to do every single time. Expand it out. Why? Because now I can use one of my methods, FOIL or box. What do we, box? Okay? So it's a 2 by 2. Two x minus 3, 2x minus 3.
I was going to say, doesn't have to be like 2x minus 3, 2x plus 3?
That is a perfect square trinomial. It's different, but that's that is true. That does exist. All right, so if I go through this, I get 4x squared. This is minus 6x. This is minus 6x, and this is plus 9. If I use my little diagonal thing, minus 6x together gives me 4x squared minus 12x plus 9. Compare that answer to what we had over there. What's missing? Yeah, you lose the middle term if you don't do this, right? It ignores the middle term, and you can't do that. You want the right answer. So don't do that. Do this. Now, one other little small example. What if I had 2 times x minus 4 squared? Could I distribute that too?
Yeah.
1.
You distribute the x minus 4 to 2, and you leave the 2 outside.
x minus 8.
Then you get the full answer.
You
and
distribute and then you kind
Wait,
of.
Let me ask you a question.
Can I say this?
Yeah, go ahead.
Because then you get the answer, and the 2 is outside. Then you multiply the 2 at the end.
Yes, at the end. I agree. But right now, can I do it?
No.
No, because I have multiplication and I have an exponent. What comes first? Exponents, right? So I can't just distribute through this 2. That would violate GEMDAS, right? What's better to do is to expand it out first. So don't distribute. Expand and distribute at the end. Okay? So what do I mean by that? This should become 2 times x minus 4 times x minus 4. Right? And then if you did box or FOIL here, you would find out that this is 2 times x squared minus 8x plus 16. Just trust me on that one.
Wait, are we just boxing the x minus 4?
Yeah, you only box x minus 4 times x minus 4, and you would get this. And now you distribute, and you get 2x squared minus 16x plus 32. Okay? Way different than if I had distributed that 2 right away and then squared it. Okay? It's all about those order of operations. All right. So we have about 10 minutes left. If anybody wants, I have some practice with FOIL and box that you can take.
Don't have homework?
But we can just go to our homework. That's fine. Okay? So,